So, my name is Jon Komperda. I am the Director of Undergraduate Studies in Mechanical and Industrial Engineering, as well as Engineering Management. See, now my AI camera is doing something goofy. Um, I'm going to try to tell you as much as I can about our program in a short period of time, but do not be afraid to interrupt me, ask questions, or raise your hand or just speak. I prefer an interactive audience. So, a little bit of information about MIE. We have 39 faculty. We've grown two since fall 2023. I believe we'll have two to three more coming soon. So we're still adding faculty. Our average course sizes are pretty personal. In ME, we're averaging between 39 and 42 students in the core curriculum. In IEM, we're averaging about 34 students through the core curriculum. We have a total of 817 undergraduate students at the last count. And I think I mentioned this leading up to this. We are a very diverse department in terms of what we do. We have everything from data mining, machine learning, high performance computing, which is an area I'm involved in, mechatronics, robotics, which Professor Bonsule, who's here, he's involved in that area. We have thermal fluid sciences like combustion, propulsion, turbulence, battery technology, material synthesis, all home in MIE. We have three main degree paths that I'm going to talk about. And the first one is mechanical engineering. It seems like a kind of traditional degree that you don't normally think about computing. But the fact of the matter is that mechanical engineering is very computationally heavy. And you'll see later that we do a lot of computing in our major to solve problems. However, we're more on the applied side of computing. All of the highlighted classes are where you would expect computing inside of our curriculum, like CS 109, where you learn how to program, IE 342, which is a required class across mechanical, industrial, data science, and computer science, ME 328, which is a programming class just for mechanical engineers, ME 396, where we do simulation and programming for senior design projects, ME 312, where we do dynamic systems and controls of those dynamic systems via programming and circuitry. But that's not where it ends. I'm showing you our new curriculum where we have 4 technical electives plus a free elective, meaning you have up to 5 classes that you can pick what you want to do with your degree. This gives you a lot of freedom and flexibility in building your own path. The same thing happens in our industrial engineering degree. However, on the IE side, we're more computationally intensive. So you'll take that same CS 109, that same IE 342, but then you have courses like IE 345, IE 348, that's specifically machine learning and data science for engineers. We have a dedicated course for that. IE 471, Stat 362. Some of these are statistics classes with computing and languages like R. Other classes are in Python for AI ML. Some classes use Minitab. You actually get exposed to a very wide range of software, simulation, and programming languages for different tasks in the industrial engineering processes. And similarly, you get 4 technical electives where you get the freedom to pursue your interests plus the 1 free elective. Then we have our engineering management program, which is a little bit different. It's sort of a hybrid of industrial engineering, but also with a business aspect. So if you're interested more on the business side of engineering, engineering management is actually the degree for you. And you see here that we have classes like management, marketing, um, as well as economics and other courses like finance mixed in with an engineering degree. So you can go into the business side of engineering. Now, I highlighted because I know many of the students here were originally applying to CS. I highlighted some of the classes you would be interested in our curriculum. I mentioned this IE 348, Artificial Intelligence and Data Mining for Engineers, ME 494, Data Science and Machine Learning for Mechanical Engineers, ME 410, Automation and Robotics Applications, Mechatronics, Virtual Automation, We also have additive manufacturing processes. This is a fun class. You build your own 3D printer and program it. Manufacturing information systems like linear programming models for how does flow go through different manufacturing systems. We have discrete event computer simulation applications, stochastic processes, and queuing models. All of this can be taken as a technical elective in our program, and it focuses on software, simulation, programming, algorithms, the applications of software, artificial intelligence, machine learning, and computer vision. So we are computationally heavy. So this is that slide I was going to get to, employment post-graduation. Something that you will see, this is directly from the Bureau of Labor Statistics, BLS.gov. These are the types of fields that our students go into. Data analytics specialist has a median pay of 103,500. The job outlook is expected to grow 35% in the coming years. This is not a saturated job market. We need to add people here. And you can do that as an industrial engineer and an engineering manager. Industrial engineering, also 96,350, 12% positive job outlook. Mechanical engineering, 96,310, 10% positive job outlook. Nuclear engineering, plus 1%. It's staying relatively flat, but very high salary at 122,480. Engineering manager, for those of you interested in our EM program, median pay is 159,000 plus with 4% positive growth. And aerospace engineering, 126,000, positive 6% growth. And this is just a short list of things that you can do with an ME, IE, or EM degree, because the MIE field is very, very broad in application. And if we start getting into the nitty-gritty details, especially around salary data for specific job titles, if you look at things like robotics engineer, computer vision engineer, they're well in the hundreds of thousands. Then if you go more in my line of work these days of high performance computing and computational fluid dynamics, thermal simulation performance engineers, 139 to 175,000. Multi-physics simulation software engineers, 113 to 135. Industrial vision engineer, I will show you a project about that later that my students are working on. Advanced manufacturing, additive manufacturing, these are kind of, when I say advanced manufacturing, I mean emerging technologies like using AI, computer vision for automation of processes, 87 to 103. Additive, which is additive manufacturing like 3D printing. And then one that I added because of our department head, he's in this area, healthcare artificial intelligence engineer. Somewhere where our IE fields can go $102,000 average. Now, note that some of the sources are from salary.com, the ranges, the other ones are from ZipRecruiter. So this is the salary data that I wanted to present to you. When I talk about employment statistics, specifically from our program, I have to first note that this is survey data conducted by UIC's Office of Institutional Research, and it's based on respondents. So I looked at the numbers, about 70 to 90%, depending on the year and the major, responded to the survey. But we see in mechanical engineering, 99% to 96.8% career outcome rate. A majority of our students become employed full-time. You can see between 22 and 23, we went from 5.2% to an increase of 7.5% graduate school. And students seeking employment, meaning that they were unemployed at the time of the survey, are extremely low at 1% in 2022 and 3.2% in 2023. In industrial engineering, I put an asterisk there because it's a smaller sample size. It still was approximately 70% of the graduating class. But for those respondents, the career outcome rate was 100%. In 2022, we had a very large portion of students go to graduate school. So we had 90.9% employed. The remaining 9.1% went to grad school. In 2023, for all of our respondents, 100% went into industry. Now I'll show you what our students are actually doing while they're in our program. So I know there's a lot here, but if you look at the top right, that was one of our drone competition teams. We won third place at the inaugural HBCU MI Army Research Lab drone competition. We have regular industry partnerships where our students are working with Fermilab, companies, national research laboratories. At the top right, you see our NASA Lunabotics robot. That was actually taken to, I'll show a video of it later, but we went to Orlando and tested it in a simulated moon environment. We worked with the US Army to develop an autonomous self-charging drone that was done by our undergraduate students as part of a grant. We build race cars and program their fuel management systems from scratch. Um, we're at the Chicago Auto Show. We're working with the Army. We're working with companies. It's all over the place. You have so many opportunities inside of our program. And then when it comes to the capstone, we do amazing things in our senior design as well, which I'm part of. We have more than 60 corporate sponsors, 10 technology disclosures where students are named, 4 patents where students are the inventors. Just in the time that I've been here, you could see some of our sample projects, including robotics. We made components for Metra that are currently deployed. Top right is a fully autonomous drone. And all of these companies that we partner with are looking for our students and to experience, for them to experience what their companies are like and potentially hire them out of our program. So here's an example of one of my current projects my students are working on for Fermilab. We were given the problem that at Fermilab, they have an accelerator, specifically the NUMI project, um, that is a radioactive environment. It's inside one of the underground tunnels, and they're using this to generate various particles and send them through the earth for measurements. However, when this needs to be serviced and maintained, they have to shut everything down, and this is a radioactive environment. So what they tasked us with was developing this fully autonomous robot that uses computer vision and machine learning and AI to identify nuts and bolts on flanges and autonomously, without human interaction, disassemble it for repair inside of that radioactive environment. That way, we don't have to send humans into such radioactive environments. This project is sponsored by Fermi National Accelerator Laboratory right here by Chicago and Batavia. And this is all performed by undergraduate students in mechanical and industrial engineering. I also want to say we have our expo Friday, April 19th at 12 p.m. at Credit Union One Arena. If you want to see these in person, what our students are doing, talk to our students and get a feeling for what our program is about, I welcome you to attend. It is open to the public. Come ask my students questions about what they're doing with their degree, where they got jobs, and what they plan for their future and why they love UIC. It would be great for you. Here is our NASA Lunabotics robotic mining competition robot. We won the Judges Innovation Award. You could see me in the middle there. This is being tested at UIC in the video on the right. Unfortunately, I didn't get a good video in the simulated lunar environment because the dust that was inside of there is a carcinogen and it's respirable. So they didn't want people taking photos inside unless you were in a full suit, like you see the 2 students here fully suited up. We had our U.S. Army Combat Capabilities Development Command drone team. They made a self-charging, fully integrated, semi-autonomous drone for the U.S. Army, where we won 3rd place. I got that huge check over there sitting in my office. We have numerous partnerships with, like, for example, Santos Technology, where we're doing ergonomics research inside of the program. This is part of our human and mind engineering research lab, where students are working on with this software and developing it for ergonomics research of humans. And then it continues to what our graduate students, undergraduate research experiences, and what our faculty are doing. So on the computing side, we're rather heavy here. Oh, do I have a question? Oh, there was the expo. Sorry. Our smart manufacturing, Smarture lab is very, very hands-on in terms of the computer foundations of additive and hybrid manufacturing. We're doing a project with them actually of doing a drone that could 3D print while flying and do repairs on things like bridges and concrete structures or other structures like homes at this current time. So in the lab, they're doing data-driven decision making in these robotic systems. So things like swarming, 3D printing, additive manufacturing, all done via data-driven decision making, either via AI or ML. And these are collaborative robots or collaborative drones that are actually interacting with each other and making decisions as they're doing this. Furthermore, they have generative AI for 3D printing applications, where they're actually looking at different applications of aerospace, medical, industrial, and they're doing experiments as well as generating AI data so they could reveal these sort of hidden patterns using machine learning to optimize the end product. We also have a lot of research that's going on in collaboration with Argonne National Laboratory, especially on the huge GPU computing. I cannot emphasize how huge GPU computing that's being used for things like material design, extracting information from experiments, and actually synthesizing new materials to be used in either manufacturing or other processes. This is from one of our faculty, Dr. Or Professor Subramanian. So they're doing this autonomous synthesis of metastable and nanoscale materials, which they're trying to do this as an AI workflow, creating these metastable phase diagrams. I'll let that video play for a little moment there. So you're seeing that sort of merging of robotics, AI programming, and then the hard physical product, which is the mechanical design of these processes and systems. Then, in summary, he had so many projects. I can only include so much with the time that we had, but they're doing everything from neural networks. They're looking at different types of materials and their stability. They're doing physics-based training. So we've been working on a project together um, where we're trying to link simulation with artificial intelligence to improve the design of automotive components to lower their weight while increasing their rigidity and lowering their manufacturing cost. So we're using AI in slightly different ways than you would think from a traditional computer science approach, because we're using it to have a mechanical engineering outcome, like a car part of making it lighter. From one of our other labs, Dr. Anahida, she's really been working with fair learning outcomes for students and this kind of fairness approach and removing bias from AI and ML. So they have this tool called Fair Pilot, which tries to do fair model selection and is publicly available. You can find this on GitHub. And then this was actually applied for ensuring equity and transparency in different sectors. So trying to understand where does the bias come from and how can you introduce fairness into these ML algorithms. So that's what I have, and I want to open up for questions. I had a little bit of extra time here, so I do have some extra slides I want to show. I didn't have time, but before I get to the questions, here are just some of the patents and intellectual property disclosures with myself and my students. All of these students after my name are undergraduate students that were named. And this was all done through our senior design program. And that, sorry, the video is loud. And we build race cars from scratch and race them with other universities. And our students are also involved in AIAA, where we build rockets, drones, and miniature aircraft that we compete against other universities. So all of these have opportunities in the MIE department. By the way, that race car that I showed, that was the thing that got me into automotive engineering in the beginning, was building the first generation Formula car we built in 2006. Do I have any questions?